In this lesson we are going to do some more 2D problems. Let's start with this one. Please pause to read it. In part 1 we are asked to find the area of triangle PRS in terms of x and theta, but we cannot start with this triangle because there is no theta in it. We therefore need to start with triangle PQR, which does have theta in it. We are given that QR is equal to PR, so both are equal to x. And because this is an isosceles triangle, we can state that angle P1 is equal to theta. We can therefore state that angle R2 is equal to 2 theta. Can you see why? Yes, because angle R2 is an exterior angle of triangle PQR. And because we now have theta inside triangle PRS, we can use it to answer the question. We have two sides and the included angle, which means we can use the area rule. We then simplify to get the answer. Please pause to check my working. To answer part 2 is easy. We substitute 5 in place of x and 58 degrees in place of theta. We then use a calculator. Please note, it is possible to answer part 2 even if you could not answer part 1. Please pause to check my answer. Here is the next example. Please pause to read it. PR bisects angle P means that both angles at P are equal to A. We can also state that angle S is equal to A because it is given that RS is equal to PR. In other words, triangle PRS is isosceles. This means that angle R1 is equal to 2A because it is an exterior angle of triangle PRS. We are now ready to use the sine rule in triangle PQR to answer part 1. This means that QR is equal to x times sine A over sine 2A, which is what we were asked to show. Please pause to check my working. To answer part 2, we need to use triangle PRS. We can state that angle R2 is equal to 180 degrees minus 2A, because angles R1 and R2 are angles on a straight line. We can again apply the sine rule. And using the reduction formulae, we can rewrite sine 180 degrees minus 2A as sine 2A. This means that RS is equal to y times sine A over sine 2A, which is what we were asked to show. Please pause to check my working. To answer part 3, we need to divide RS by QR. This is the same as multiplying by the reciprocal of QR. We then cancel the factors sine A and sine 2A, leaving us with y over x. We can now use the fact that x is equal to 4 and y is equal to 8. Next we substitute. RS over QR is therefore equal to 2. Please pause to check my working. Let's end with this example. Please pause to read it. It is given that AC is equal to CD, so both are equal to x. And by now you should know from geometry that the angle in a semicircle is a right angle. This means that the exterior angle ACD is equal to 90 degrees plus theta. We can now use the cosine rule in triangle ACD to find AD squared. X squared plus x squared is equal to 2x squared. Minus 2 times x is equal to minus 2x squared. And using the cofunction reduction formulae, we can rewrite cos 90 degrees plus theta as minus sine theta. This simplifies to 2x squared plus 2x squared times sine theta, because a minus times a minus is a plus. We then take our 2x squared as a common factor to answer the question. Please pause to check. To answer part 2, we substitute root 27 in place of AD and 3 in place of x. Root 27 all squared is just 27, because the square and the square root cancel each other out. 3 squared is equal to 9, so 2 times 3 squared is equal to 18. Next, we divide both sides by 18. 27 over 18 is equal to 3 over 2, or 1.5. Next, we subtract 1 from both sides and get that sine theta is equal to 1/2. And because we are not allowed to use a calculator, we need to use the special triangle. Theta is therefore equal to 30 degrees. This completes the lesson. Good luck with the test.